Hello, scholars. Today we're going to talk about paired samples t-tests. They are also called dependent t-tests or repeated measures. These t-tests measure two time points, a within groups factor. So typically we have one group and two time points, such as a pre-test and a post-test, or it could be, end of fall and the end of spring, or it could be end of year one and end of year two. You have two time points. And we presume that the testing conditions have changed. Okay. So, for example, is there a statistically significant difference in blood pressure after patients were given a new blood pressure medication? The independent variable is time, with two categories of pre-test and post-test. The dependent variable is the blood pressure reading, and the intervention in this case is the changed testing conditions. What's changed? We gave them an intervention of blood pressure medicine. So let's stop and think for a moment what our data file would look like if we just had paired samples or dependent samples t-test. We would have two columns of scores. Notice there's no categorical variable here like there is for an independent t-test, where one column is a group, one or two, and the second column is a score. We have two columns of scores. The concept of time is separated in our thinking. So we label them pre-test or post-test, but each of these columns you would label with a time point. Okay, we have another example. Is there a statistically significant difference from fall to spring in height for third graders from an urban school district in Ohio? Time is the independent variable with two categories. This time it's fall and spring. Height is the dependent variable, and we have one group of third grade students from an urban school. Okay, and we assume that the changing test conditions is the passage of time because children grow. Okay. So a paired samples t-test has data assumptions and testing assumptions, just like we've talked about before. The data assumptions includes one within groups variable with two categories of matched pairs or related pairs. So time, pre-test to post-test, something like that. Okay. One dependent variable measured at the continuous level. So ordinal data like ranked data, Likert scales and stuff, we typically use a different test. And the testing assumptions include no significant outliers greater than 1.5 steps from the edge of a box plot and approximate normal distribution. We use a Shapiro-Wilk test for that. So now let's take our data set and run a paired samples t-test in JASP. So I'm going to open my file. If it doesn't already show, click Analyses, and then I'm going to go to t-tests, and I'm going to go to paired samples t-test. And now notice I just have variable pairs here. There's not a split group or categorical variable there. So we have day 1 and day 2 for weight. Okay. The student t-test is the parametric test. Here's my non-parametric test. And here are my choices for alternative hypothesis. And I'm going to select the two-tailed test, saying that things are not equal. Here's my effect size and my confidence interval and the descriptive statistics and my normality test. Okay, and those all show up here. Now, I also will show you how to make our box plot again, so you can inspect one for significant outliers. So to do that, you're going to go to Descriptives, Descriptive Statistics. First, under Statistics, we need to move our variables back. Day 1 and day 2 is what I'm using. Under Descriptive Statistics, I'm going to select quartiles. I'll need that in case there's outliers. And I'm going to select IQR for interquartile range. And now I'm going to scroll down to customizable plots. And I am going to click box plots. I'm going to make sure box plot element is the one that's selected and label outliers. And you should be able to see everything that's showing up here. Okay, so now let's talk about interpreting our test. All right, so the first thing I want to do is I'm going to run my normality test. And you can see from figure 1 here, there's my measures day 1 and day 2, my t-value, my degrees of freedom, and my p-value. Now remember, the p-value, if it's less than the alpha, I reject the null. If it's greater than the alpha, I fail to reject the null. The alpha for social sciences is 0.05, a 5% chance of a type 1 error. Okay, so this is my t-test. Here's my normality test. Okay, my p-value is 0.629. I am testing the null hypothesis that the data is normally distributed. P is greater than my alpha of 0.05, so my test here is normal. W for Shapiro-Wilks statistic 0.985, and P is 0.629. So I fail to reject the null hypothesis. There's not a significance. The assumption of normality is met. Okay. Now for violated assumptions, let's say my assumptions were violated and now I want to know if there's a big outlier there. I'm going to go look at my box plots, right? There's day 1 and day 2. Okay. So let's look at that, day 1 and day 2. On day 2, I have one outlier on the upper threshold, case 53. So what if I want to know if that is greater than 1.5 steps from the edge of the box, if it's significant? Refer to my videos on correlations, but I can show you the formula here. Okay, to calculate if it's greater than 1.5 steps from the edge either direction, right? For the lower threshold, it's 1.5 times the interquartile range, and then we take that number and we subtract it from quartile 1. So let's scroll up and look. I highlighted it for you. Here's our interquartile range, right? And here's the 25th percentile right there, right? And then the upper threshold uses quartile 3 times 1.5 IQR. We add them, we don't subtract them. That's the difference. Okay, so my interquartile range was 1.64.733. I multiply that by 1.5 and I get 251.5995. Now I'm going to add my quartile 3 to it, and quartile 3 was 13.16. I add them together. Here's my total. And any score that is above 264.7595 is greater than 1.5 steps from the edge of the box. So we know that this is case number 53 under day 2. So I can go look at my data. I can scroll down to case number 53, and I can go to day 2, and that one is 184.737. That is not greater than 264, so it is not a significant outlier. Okay? So I don't have to worry about this outlier. It's not violating normality. Now I'm going to tell you right now, if the outlier is violating normality, you can change tests. You can check to make sure your data points are correct, but you don't just drop outliers because they're inconvenient. You have to have a reason to drop them. Okay, so typically, if it was a real big problem, I'd just change tests to the non-parametric Wilcoxon signed rank test. I would use that if I had ordinal data or if I had violated normality. Okay. Okay. Now, you interpret the t-test and the Wilcoxon signed rank test the same way. So remember, we're testing, is there a statistically significant difference in weight from day 1 to day two? And here are my hypotheses. Okay, and here's my paired samples t-test. P is less than 0.05, so I reject the null. Okay, and this is how I write it in APA. T parentheses, degrees of freedom, which is 63. The t statistic equals 7.9453, comma, the p-value. And the p-value is less than 0.001. Okay. And I color coded it so that you could see it clearly where I was getting everything. Now you interpret a Wilcoxon signed rank test the same way. So I highlighted it. I ordered it at the same time I did my paired samples t-test, right? And here I'm going to use the z statistic. And I'm going to do z equals 5.2 or 5.952, comma, p equals, or p is less than 0.001. It was also statistically significant. Okay. Now, my post-hoc testing, there's just one of two ways I can go. If I had a significance, I report an effect size. If I did not have a significance, I usually do a post-hoc power test to see if my test was too weak. So let's say, well, I had a significance, so let's look at that. Okay. In JASP, you check the effect size box and the confidence interval under testing, right? And here's the output. I color-coded them for you. So the effect size for both the Wilcoxon and the paired samples test is right here. Okay. So D equals 0.993. That is the effect size. Or D equals 0.856 is the effect size for the Wilcoxon signed rank test. Okay. If there happens to be a negative sign here, I would not need it to report an effect size. Now I can tell you right now, I wrote out my t-test results again here, comma, D equals for Cohen's t, my effect size, and I use Cohen's cutoffs to determine how large my effect size is. So here's a chart. An effect size from 0 to 0.19 is no effect. From 0.2 to 0.49 is a small effect. From 0.5 to 0.79 is a medium or moderate effect. And 0.8 and above is a large effect. Let's see, 0.993 is a large effect. It's over 0.8. Now, if you want to do a post-hoc power test, most people don't require it, but I always want to know. I use G-Power. Some other softwares you can order the power test right when you use it, like SPSS. Okay. Here's my G-Power. I selected my test, mean difference between matched pairs. I selected post-hoc. To tail, I entered my effect size of 0.993, my alpha 0.05, and my total sample size. And the total power of my test was 1.0. That's as powerful as it can get. The power of my test was huge. That's a really strong test. But I don't need to report the post-hoc power because I found something. I would report this if I didn't find something because I'd want to know if the test was too weak. And remember, a weak test, we figure 0.8 or 0.95 for social sciences. If you're getting way down there, 0.3, 0.1, that's a really weak test, and it might not have been strong enough to find anything. Okay. Now I'm going to report my conclusions and findings in APA 7 format. So here's what I wrote. A paired samples t-test was conducted to compare day 1 and day 2 in weight. A Shapiro-Wilk test indicated that the assumption of normality was met, W equals 0.985, P equals 0.629. The results of the t-test showed a significant, large difference between day 1 and day 2. T parentheses 63 equals 7.943, P is less than 0.001, D equals 0.993. The mean difference was 14.644, and the confidence intervals ranged on the low end from 0.690 to the high end of 1.290. The researcher rejected the null hypothesis in favor of the alternative. There is a statistically significant difference in weight from day 1 to day 2. Notice that I stated the hypothesis that I did not reject. I provided that to be clear. This is part of my conclusion. And I stated some of my conclusion in here, showed a significant, large difference. Okay. So in JASP, you need to remember that it's not printing off the mean difference between scores. So I needed to use the descriptives that we printed off, that we did right here, and calculate the difference. So 173.98 minus 159.34. And that's how I came up with my 14. Okay. Okay, well, reach out if you have any questions. Thank you for your time.